So welcome again to MOBILFUNK Livestream. Some people are still coming in. The concept of this format is to give our partners and our industry expert in digital hub mobility and our startups a stage to provide food for thought for you, interesting insights, connections, ideas, and contacts. So please listen, join in the discussion, post your questions in the Q&A section, and join us later in our networking session. What you can do is use the Q&A section to the right. Please don't put the questions in the chat, but put them in the Q&A so that others can upvote the questions that they find most interesting. How we do the networking, I'll explain at the end of this hour. So today we'll talk about 5G with our partner Nokia and with the startup Fernride, the remote operations startup from Munich. And Nokia has been a partner at Digital Hub Mobility from the very beginning. They're a very trusted partner. They've done several really interesting projects in our digital mobility lab, for example, on drones or a 5G bicycle bell that protects vulnerable road users. And so just as a brief overview, we have 3 experts from Nokia here today, Peter Merz, Tom Richter, and Uwe Pütschler, and Henrik Kramer from Fernride, who's also presenting his activities and his startup. So quite a packed program, and I suggest we get started. Peter, you are head of standards at Nokia, and you're here today to give us the big picture on critical networks. Please introduce yourself, and we're really looking forward to your presentation. Welcome.
Okay, many thanks, Christine. It's a great pleasure to be here, and it's also a great privilege to open the scene. So I will try to give you a bit an overview how 5G will help in terms of the digitalization, and Uwe Pütschler and Tom Richter, who will then also give you concrete examples how 5G will empower digitalization. I'm with Nokia and I'm leading the standards organization. So we are the ones who define how 5G will work, and we have already now started the adventure to look into what comes after 5G. So stay tuned to hear what 6G will be in 10 years from now. This is a picture we have taken from the Olympic Tower, and you see when we talk about MOBILFUNK or 5G wireless communication, it's also about coverage and to provide the connectivity for all those critical networks and for the users consuming it. So before we start, Nokia at a glance. Nokia is a company with a history more than 150 years. We had been in the paper industry, creating rubber boots, tires, televisions, and mobile phones. And nowadays, we are an infrastructure company. And the company, you see here the key numbers, so 22 billion net sales last year. We are strong in innovation in terms of the investments we have done over the last 20 years, which also then results in a strong patent portfolio we are licensing to all the partners who want to utilize those technologies. And in the following, I would like to give you a bit of setting the scene, what 5G will do and what this 5G does in terms of the networking. And when we see networking, which is the invisible things, when we make a phone call or when we surf the internet, and it's determined by 3 things which play into each other. First one is that we need to boost the performance of those networks. And when I mean performance is so that we minimize the total cost of ownership. So the assets we are optimizing here is like the tower, you have seen the Olympic Tower, like the air we are using, also the airwaves, then the light when we transport the bits and bytes over the fiber network into the cloud, and then for sure as well then also the power, so that we ensure that we optimize the power consumption. What we see now as a trend is the agility needs to be boosted, and that means by means of utilizing web-scale technologies, that you can, what we have been doing previously in hardware is now being done in software in a very agile way. And what we see also that in the future, we need to much more turn the complexity into efficiency and to provide those services which the network operators wants to have in a as a service consumption model. But now let's come to 5G. 5G is the foundation for critical networks. And what do I mean with critical networks? So critical networks we have all been experiencing during the last 2 years almost, because they are providing the critical consumer connectivity. When we work from home, when we work on the move, and if the internet is not working, then we complain and we see how critical those networks are. What is the next phase, and what also Tom and Uwe will articulate, is in how 5G will play a role for industrial networks and for critical communication, what the industries are asking for. And those critical networks have different dimensions, as you will see, so that they are either there in order to provide the required capacity, that they provide supporting low latency applications, or that we provide high reliability when it comes, for example, connecting cars and controlling the cars. 5G is a highly standardized environment, and I will not go into details, but it's based on 3GPP specification, and they are not done in one shot, so they are evolving as there are different releases. So the foundational release is called the release 15, which provides the foundation for all those networks we see currently in commercial use. But it will also evolve over the next releases, which will be put into commercial use. So Tom will talk about what it takes to bring 5G into a factory, for example, and what are the necessary bells and whistles we need to bring in order to provide those frictionless critical networks. And then you will also hear from Uwe how 5G and the related connectivity will allow to do connected mobility. Good. I mentioned the system performance, which is key. So what are those things and what are those numbers you might hear throughout the networking event? So we talk about speed, and 5G is amazing what it does in terms of providing speeds up to 10 gigabits per second. We talk about latency, which is like a fingertip, which is important to do seamless surfing or to control robots, for example. So that is especially important how to power Industry 4.0, for example, in a smart factory environment or on an oil rig. So here we talk about real-time and remote control of things which are moving in those shop floors, for example. Uwe later on will talk what it means to have this connected mobility with the long-term vision that we have autonomous cars, which then set different requirements, because we need to have rock-solid connectivity in terms of reliability, because you need to guarantee that the car makes a stop. And this also requires, as the car is a fast-moving vehicle, that we need to react in real time almost, so the latency matters. And you see here many more use cases 5G is going to unlock. It's almost infinite, but we will take you then on the journey how we power those things by means of the 5G technology. As I already mentioned, we in the standardization and the research are already looking and giving a glimpse into 6G. So 6G is something we expect to arrive commercially in 10 years from now. But as we have longevity when it comes to technology development and then also the related standardization and the verification, work has started in various research environments. Also Germany, with the German government, is investing a lot of money as we speak right now. But we also see that this 5G, as I have already introduced, is advancing into 5G advanced, where we will try to provide an even better experience. We will try to expand what the network is going to offer in terms of services, and also to extend the range, for example, to bring 5G to non-terrestrial networks, or to extend the application of mid-sized sensor services. 6G is still in the fuss a bit, so it's about blending in of what we call here the physical world, the digital world, and the biological world. So I would guess we will have another MOBILFUNK Livestream then on 6G when the time is ready. And with that said, I would hand over to Tom, who will give you then a glimpse of what 5G can do in order to power a smart industry and smart factories. Many thanks for the attention, and looking forward for the networking later on at the tables.
Thank you, Peter. Thank you very much. That's very interesting. And maybe later you can also, I have many questions already, Like, how is it possible to increase the latency tenfold or decrease it tenfold within only a few years, like you showed on your chart? That's really amazing. So I think there's going to be a lot of questions coming up on that one. Tom, you're head of manufacturing verticals at Nokia, and so you're responsible for deploying 5G industry solutions. Please just tell us a little bit more about where these 5G industry solutions are the most relevant and where they are relevant for mobility. Thank you.
Thank you. Yeah, I will do so. So firstly, when you had a chance to visit us at several locations in 2018 or 19 at the Hanover Fair, for instance, then you may have seen our factory in a box, a prototype of a real production line based in a container, being able to be shipped around and to produce wherever you need to produce. This is mobility coming to manufacturing. Also, as late as when we see the first 3D printers producing goods on transfer on the ocean, for instance, then manufacturing becomes mobile. But I don't want to talk about those ones today. I want to focus rather on intra-mobility in the factory and on the shop floor. My name is Tom Richter. I'm the head of manufacturing verticals in Nokia. And in this capacity, I consolidate our expertise and experience we gain by supplying our products to manufacturing customers. So talking about mobility, intra-mobility in manufacturing. You may have seen concepts of that, for instance, from Mercedes-Benz when they launched the Factory 56. You also have seen this with Bosch when they advertised their intelligent floor, which means that the floor is intelligent in that it realizes what is on that floor. Or you also may have a look at KUKA, who cultured the concept of a very flexible production factory floor, and that the KUKA robots can be moved around according to the needs. And this brings us exactly to the vision of a future network, which needs to be able to serve those use cases. And the vision is that we have all the goods connected, because this is a precondition to be able to deal with them and to talk to them. It is also that such a network needs to support the ever more mobile assets to let them design in a very flexible layout there. This will enable cognitive supply chains in that you have the incoming goods as well as the goods in production, as well as the products going out to the customers being traceable all along the value chain, and that the value chain in itself, the supply chain in itself, becomes more and more intelligent, fueled by data and by self-learning processes and artificial intelligence. There are two concepts discussed at the moment. The one concept is the so-called lights-off factory. So this is a factory without any human interference, without any worker on the shop floor. There is an opposite concept discussed at the same point of time, which says there will always be a worker, just that the role of the worker will change dramatically over time. And exactly for that concept, which seems to be the very likely concept also for the next coming years, we need to support the workers by doing their job on the factory floor. And here it is about augmentation. It is about to connect the worker, to give them additional senses and to give them additional means to produce and to consume data. And last but not least, we will see a lot of remote controlled and remotely operated machines, which work fully automated and which again use self-learning algorithms, etc., to be controlled. And for this, again, a network is a crucial kind of infrastructure. Such a network may look like this, and this is certainly something for the techies, and I will go over that one very quickly. On the left-hand side, we have the devices, and when we talk about manufacturing, we see a lot more different devices than in the consumer space. Here it is about cameras, sensors, location tags, AR/VR equipment, and machines, robots, etc., etc. On the right-hand side, we have business applications. Business applications have matured to that extent that there is today a real need to connect these business applications with the devices. And exactly in that gap in the middle, we provide a 4G or in future a 5G network, which is capable to connect the devices with those applications, which may be hosted on a corporate cloud, which may be hosted on-premise or in a public cloud, wherever it is. Talking about mobility. To support mobility, we have different options here. With our campus networks, we focus on the right-hand side, we focus on the business critical and mission critical applications. Here it is to support the automation equipment requirements, to support the critical machine-to-machine communication, etc. And I will come to that in a minute. On the other side, on the left-hand side, we see the public networks. And the public mobile networks, also equipped with 5G, will certainly play a crucial role, for instance, for supply chains and for interlogistics. Whenever we need to track and trace products, to monitor products on their way between different manufacturing sites, for instance. So these two have a role to play. My focus will be on the right-hand side for the next coming minutes. But what is also to be stated here is that today's networks which are in use for manufacturing, namely Ethernet LAN, as well as Wi-Fi networks, they appear to be not good enough for the needs in the future. When we have a look at a production site, and I give here the example of the process industry site, and we looked at the use cases which we can enable in a holistic manner. And it starts with the campus itself. On the campus, you see use cases for facility management, for instance, or for the support of facility management with multifunctional drones. Again, you need a network for that, and this is a wireless network. When we talk about the automated plant as such, then we talk about use cases like, for instance, machine-to-machine communication. And as I explained, machines become more and more flexible. They need to be moved around. And again, the cable connections are not the preferred way of doing this, and therefore we need wireless communication there. The connected worker we have spoken already about, and here it is about augmentation to bring augmented reality, virtual reality workers to do, for instance, maintenance tasks, or to carry out, for instance, also training. On the other side, we will also see, specifically in hazardous environments, the so-called connected wearables, where you equip the wearables of the worker with a whole lot of sensors or cameras, which make them visible to the operation systems. Then to talk about the assets. We have thousands and thousands of dumb and smart assets in a plant or on a shop floor. And it's a sort of no-brainer. We don't need to talk about the automated guided vehicles, which certainly cannot be supported by a cable, and Wi-Fi networks are not good enough because they don't support the true mobility. And all of this is supported now by products of ourselves, either with industrial fixed networks or private wireless networks, what we are focusing on today, but also with multi-site interconnect or with seamless global connectivity, for which we have products in our portfolio. Now, so let's talk about some references and what we have done. When we look into references, then we can distinguish here between different areas of expertise and experience. First and foremost, I want to mention our Nokia factories. The Nokia factories those are the places where we eat our own dog food. And Nokia and Dulu, for instance, is an electronics factory where we produce prototypes. And a prototype production needs to be flexible in itself, because We don't produce thousands and thousands of products over months and months, but rather a couple of prototypes over a period of a couple of weeks, and then the layout needs to be changed. The Arena 2036 is a good example for a research and demo area. In the Arena 2036, companies like Bosch or like Daimler test and trial future production methodologies. And again, they try that with a network, with a 5G network supplied by ourselves. We have customer projects, and we have the first 5G standalone networks supplied and put into operation with customers, like for instance Bosch, or Rohde & Schwarz, or Lufthansa Technik, and I will come to Lufthansa Technik in a minute. And then we certainly have industrial partners, which we need to satisfy the needs of the use cases. There is not a single company who can satisfy or who can produce a use case from A to Z on their own. There are always partners around which need to combine their forces to bring such a use case to life. Let's talk about Lufthansa Technik. Lufthansa Technik is one of our customers who have deployed a 5G network end of 2019, 2020. And this was deemed to be a proof of concept at the time. What they do in Hamburg is the so-called table inspection. For the table inspection, Lufthansa Technik is calling their customers to the table. And on that table, the parts of a dismantled engine are laying. And on that table, together with the customer, the engineers decide which of the parts need to be replaced, which part needs an overhaul, or which part can stay. This is an exercise which has been done so for the last couple of years, because such an overhaul of an engine is a costly exercise in itself. This is done in a hangar, and the hangar looks like in the pictures shown here. This is a sort of hazardous environment for any wireless network because there's a lot of metal, there's a lot of moving parts, etc., etc. And the only network technology which proved to be capable of dealing with that is a 5G network. And as COVID-19 arrived and customers were not allowed or not able to fly into Hamburg, this turned very quickly into a commercial use case because now Lufthansa Technik had the means and ways to continue their business by relaying the camera pictures as seen in the picture on the left-hand side, by relaying those camera pictures over a high-performance network on the campus to the customers abroad and remotely, and the customers could stay at home to make the decisions from there. Why is such a good network on the hangar side is needed here? Those pictures, those video pictures need to be of high resolution, they need to be of good quality, and they need to be reliable in order to be able to make those decisions. And exactly this is what is being provided by the 5G network. And again, that camera is mobile. So with this, I want to close because this was my example. And sorry for taking a little longer, but over to the next.
That's quite all right, Tom. That was very, very interesting. Thank you very much for giving us this insight. Looks that you were one of the real beneficiaries of COVID in that respect then. I mean, I also read that one of the first things that happened was that airlines really started to do all the maintenance that they had always wanted to do. So all airplanes and engines now fully maintained. So that's great. Maybe we can talk later about sort of the factor of how costly this investment is and compared to the efficiencies that are gained from it, because that's something I would like to understand. But let's do that in the discussion. Uwe, you're head of automotive and mobility solutions. And so you're the one who's probably always being asked, so when will we have autonomous driving? And I don't know whether you will give us an answer to that today, but certainly you can dive into the latest on 5G and autonomous driving from your perspective. Thanks.
Thank you very much, Kirsten, for the kind introduction. I will be talking about how 5G is being used in the automotive segment, but I will definitely not answer the question finally you ask, because there is a lot of activity going on, a lot of changes, etc. But let's look into some of the fundamentals on this topic. What do vehicles need connectivity for? And the first one, and straightforward and obvious area of applications, is infotainment and entertainment. And everybody would expect to be entertained in the vehicle, and that means everywhere when you are driving. And network coverage and good bandwidth is a prerequisite for that. A second area of applications is traffic efficiency. So to get informed about the situation on the roads, get guidance how to maybe overcome some changes. And for those type of applications, again, network coverage is important because you want to get this information everywhere. The audience would expect a higher reliability of the network for this type of applications because it is more critical than infotainment. But the real challenging set of applications is related to traffic safety and automated driving. That's a very demanding area of applications because it relies on network coverage. You want to have it everywhere. It relies on bandwidth, and it requires a much more reliable network. And here we add even another quality of a network, and that's predictability. And last but not least, for safety related applications and for automated driving, low latency is very important. What we mean with predictability is also fairly clear. A vehicle, when it's driving automatically and it will rely on communications, then it is very important to understand whether the quality of the network in the area it's driving into is the same as it has at the moment, or whether the quality of the network will change. And to give the vehicle information about the upcoming network is very important, and that's what we call predictability. Now, no surprise that 5G plays an important role for the first segment, infotainment, because that's about bandwidth, and it plays an even more important role for traffic safety and automated driving, because things like high reliability, low latency, predictability are typical qualities of a 5G network, and Peter talked about that at the beginning of our session today. Now, how is communications being done in this context? Everybody knows standard connectivity using a network, an LTE 4G network, or now also 5G with a smartphone. The network connects your application on the smartphone to a server somewhere in the cloud. That's what everybody knows. Fairly similar, vehicles are connected via the network to a backend, mainly to the backend of the car manufacturer. And that is, to a certain extent, standard today. Most of the new vehicles have this capability. They are connected. Some are using this, for instance, to update software. Others are using this to share telematics information. So that's a fairly common capability today. And we are talking about close to 200 million vehicles on the roads globally having this capability already. But the automotive industry designed 20 years ago another principle, which is about direct communication or short-range communication between vehicles. So they can exchange information using radio technology without being covered by a network. So this is a type of communication which also works without the network. And that is also true for connecting a vehicle to traffic infrastructure. We call that V2I, vehicle to infrastructure, whereas the communication between vehicles is called vehicle to vehicle. And the same principle is being used for a third type of direct communication between vehicles and pedestrians, vehicle to V2P. So these are the types of communications which are being used. Common in the world today, the connectivity via the network, the direct communication, which I just introduced, is something which we are seeing just about to happen with the first vehicles, and I will come back to this in a few minutes. Now, looking at the plans and the roadmap of different use cases, I would refer, or I want to refer to an organization which the automotive industry and the telecoms industry is founded 5 years ago. It's called 5GAA, and the roadmap you see here was published last year by 5GAA, and it shows that we have already several vehicles on the market, on the roads, which exchange, for instance, hazard informations using the network connectivity. We will see more advanced use cases supporting traffic safety in the upcoming years. And from 2024 on, we will also see the first use cases supporting automated driving. And this will evolve further with more complex and more advanced use cases supporting automated driving. And just to give you two examples, from the second segment, so in the range what we expect this year, next year, and maybe in 2 years, one of the very hot areas in this automotive segment is the vulnerable road users, pedestrians, bicycle riders. So to protect those traffic participants in a much better way is one of the clear objectives of the industry, and the use case vulnerable road user is targeted to address that challenge. And what it is about, it's fairly straightforward. A vehicle wants to get warned when a pedestrian is on the roads in front of the vehicle. And that's something which requires quite a low latency. We are talking here about 100 milliseconds. Another very demanding topic is how accurate is a pedestrian positioned on the road. Obviously, you want to get a warning as a driver only when the pedestrian is really on the road and not on the footpath. And that's why location accuracy of 20 centimeters is expected. Reliability is reasonable. It's not extremely demanding for this use case. But this is different on the other use case, which I brought today as an example, so-called group start. What is a group start? A group start is obviously one use case from the set of use cases supporting automated driving. Several vehicles waiting at the traffic light for green light. They get an additional signal so that when the light turns into green, they can start driving in a very synchronized way automatically. And that's something which we will see only beyond 2026, because it's a fairly demanding use case for those vehicles. We are talking here about latencies in the range of 10 milliseconds. Again, positioning accuracy in the range of 20 centimeters, but reliability is important. 99.999% is the expected value here for this type of use cases. And that is in line with what Peter presented at the beginning for the evolution of 5G going forward. So these are examples. Now, what's happening in the market? As a first example, I mentioned the first vehicles are now on the road, which support all those types of communications which I mentioned. So via the network as well as the direct communication between the vehicles. And there's no surprise, the most momentum we see at the moment in China. You see here one vehicle end of last year. It was announced supporting these capabilities. Now we have in the range of 10 to 12 of those vehicles already in China with the same capability. China was also the first market where a vehicle with 5G connectivity is on the roads. It's a Chinese vehicle. Also, one of the European car manufacturers announced that last year to have such a car, but the first one on the road is from China. So here we see a big momentum in China. Europe has another initiative going on. It's called Data for Road Safety Initiative. It's supported by several European countries and car manufacturers. And the objective here is to exchange the information or safety-related information via the network between different vehicles from different car manufacturers. And you see also some of the use cases. For instance, a vehicle detects a slippery road. It sends the message to the cloud of the car manufacturers. That is then forwarded to a service provider, and the service provider can distribute this message to other vehicles. And you see who is participating in that initiative, and that is a way to use the investment going into the networks for more safety on the roads. A third interesting trend is the use of applications in the vehicle. Because obviously to put new applications into the environment of a vehicle, the built-in environment of a vehicle is a process which takes a little bit more time. Everybody knows putting an application on a smartphone is a much faster process, and that is being used in some of the countries. The Netherlands is probably the most innovative and advanced country in Europe in using this sort of applications, and these applications can only work properly if the road infrastructure is properly digitalized. And that is happening in the Netherlands. So we have quite a lot of digitalized traffic lights already. They are managed in a sophisticated way. And this information can also be used by those applications in the vehicles. A similar approach is taken by some of the states in the US. They are also using such applications, and they support various use cases. And one example is emergency vehicles. They can request green lights when they have to go to the place of the accident, and that saves lives as well. School zone warning is another one of the use cases, using the network to inform drivers about a special area, and a school zone is such a special area, and the driver can adapt the driving behavior accordingly. So these are examples how connectivity is being used today, what is happening in the market. And to come back to the question, now to really support fully automated driving, and here we need to make a bit of a difference between having a few automatically driving vehicles on the roads, like we expect this with shuttles, is one thing, but to have a high density of those vehicles on the road is something which will happen only in several years. And those traffic scenarios then require also connectivity between those vehicles. So that's a bit of a view into the future, and I would like to finish on that with this part. Thank you.
Thank you, Uwe. Again, I think many interesting questions can be discussed after this very interesting insight. But let's listen to Hendrik first. Hendrik, you're co-founder and CEO of Fernride. I'll introduce you a little more in detail because you're the youngest in the crowd. So you studied at Technical University of Munich and Stanford, and you specialized in entrepreneurship and autonomous driving. And that's where you also met your co-founders and you founded Fernride. You're on your way to become a European champion already for driverless logistics. And you have won several startup pitches already. You won the DE Hub initiative, from which we belong to as Digital Hub Mobility. You won our startup pitch in 2020. You won the Deutsche Mobilitätspreis last year, and also the award by Bits and Pretzels. So you've received quite some publicity already. And so you're on a really, really good track on your way to your first Series A financing round. So let's hear what you're about. You set out to empower autonomous fleets. You've pivoted a little bit. I'm sure you'll tell us some more about that also. Hendrik, floor is yours.
Yeah, thank you very much, Kirsten, for the kind introduction and the ongoing support from the Digital Hub Mobility. And yeah, thanks also for having us today, or having me today here speaking. I'm Hendrik, co-founder and CEO of Fernride. And as Kirsten already told, we are enabling driverless transportation through teleoperation. In the next 7 minutes, I explain to you what I mean exactly by that. So let me start a little bit about the background of our company. We are 3 founders. I co-founded Fernride together with Max and Michael in 2019. We met back then at the chair of automotive technologies of TU Munich, where Michael was pursuing his PhD in teleoperation and became one of the world-leading experts for this technology. And together we decided to spin off his PhD topic and the IP of more than 10 years from TU Munich and started Fernride with the mission to build a category champion for driverless transportation out of Europe. And on our quest, we are supported by several technology companies and well-financed by world-class venture capital investors that fuel our super fast growth. Currently, 30 people in Munich and growing to 50 by the end of this year. So far, so good. I think we can all agree that driverless transportation is great and that the autonomous vehicle revolution will create enormous value for our society, but it is not there yet. Why is it that way? So if we look at the reality, different challenges restrict the deployment of autonomous vehicles to very narrow operational design domains. The real world is simply too complex and there are too many edge cases that are hard to automate. And if we look even at very simple environments, like for example on private yachts, even there AVs are not there yet, even though the operational challenges of the logistics industry critically depend on automation and more automation. And by combining now the capabilities of human intelligence with the power of artificial intelligence, teleoperation can be the enabler to overcome these challenges by allowing a remote operator to assist automated vehicles through these situations over the cellular network. And this is true both for public and private domains. So for example, on public roads, even in level 4 vehicles, a safety driver is still necessary, but with teleoperation, the safety driver can be in an office and can assist the vehicle when it needs assistance. On private domains, teleoperation is already feasible today and also legally allowed. Thereby, teleoperation is accelerating the deployment of driverless vehicles and unlocks several benefits that are really game-changing for the logistics industry already today, and that's why we focused on this specific industry. Next, I would like to explain the teleoperation technology more deeply. So there are basically 2 control modes. The first one is teledrive, that just works like the local driver drives the vehicle today, just sitting somewhere else, for example, in an office, directly remote controlling the vehicle. The second mode is tele-assist, in which the teleoperator assists the vehicle only in situations it cannot handle itself. So most of the tasks are in this mode executed by the autonomous stack, and thereby the ratio between one teleoperator can be scaled to many vehicles, since they can manage task by task. So no matter what the teleoperation mode, so this is a key message, the customer, the end customer, the logistics operators get from us 100% driverless process, which is today 100% teleoperation, and step by step we automate the task on the route to full autonomy. And at one point, the teleoperator is only a fleet manager that assisting maybe up to 50 autonomous vehicles. We have chosen in our go-to-market to focus on yard trucking. So these yard trucks are used, for example, on production facilities, distribution centers, ports, to transport cargo from A to B. And these processes today are highly inefficient, since the drivers have idling times of up to 95%. And we have chosen this use case for 3 reasons, basically. So it's on private ground, so we don't need to wait for a change in legislation. Second, the complexity is lowered compared to public road traffic scenarios that enables us to commercialize much faster. And third, we do not, we can have the perfect learning opportunity, let's phrase it that way, to refine the technology in a real-world application and make it robust enough for public roads. First, for an application like long haul between the hubs, probably one of the use cases that will come earlier on public roads, and later on even more complex environments with last mile delivery. And this is not only a vision, but already live in production. So we started with this head start of more than 10 years of R&D at the world-leading lab for teleoperation at TU Munich. And over the past 2 years, we integrated our technology stack into 5 different OEM platforms and are currently in pilot projects with several Fortune 500 companies to bring this value proposition directly to the end customer. I think it's quite obvious why teleoperation and the topic of connectivity and 5G today are such a good match. And I would like for today to provide 3 key takeaways in relation of teleoperation and 5G. So the first one is that teleoperation is a great use case for 5G. So all what has been said about why 5G is so beneficial is very true for teleoperation. So data transfers with extremely low latencies below 10 milliseconds, combined with the availability of close to 100%, this becomes possible, a 10-fold increase in bandwidth, and also the fact that you can guarantee for an increasing amount of end devices with a reliable quality. So this quality of service is a fantastic feature for teleoperation, and therefore it makes us as a developer around this technology, building a product out of it, the life much easier. The second takeaway is that latency directly correlates with the velocity a teleoperator can drive. So the lower the latency, the higher the possible velocity a teleoperator can safely drive. In LTE, this means that we can drive safely around 25 kilometers per hour safely. With 5G, we can reduce the network latency dramatically, and it would be possible to drive also in inner city traffic. And as a disclaimer, it will probably never be safe enough, so this is my personal opinion, to drive on highways with teledrive. I would not advise to do so. I think automation in this ODD is the better choice, and tele-assist is the backup option for scaling this ODD for an autonomous vehicle in these scenarios. The third key takeaway is that if we put all these great promises aside, 5G is not rolled out yet, and we can't and we won't wait for it. So at Fernride, we are developing a safe and fully functional system that works already with 4G today. We use 4 SIM cards in our connectivity module and combine the streams with multiplexing technology and channel bonding to create a very reliable link. So we are simulating or recreating the functionality that is associated with 5G and try to have the same functionality as in 5G and even in 4G. So if the connection should be lost anyway, since we do not have this quality of service, what is a great feature, our health manager introduced a safe stop. In our deployments on yards, this works perfectly already today and is ready to use. But as a key takeaway, 5G would make our life much easier, but can't wait for the rollout, especially on public roads. I think this requires still some time, and happy to discuss this later on in the discussion. So thank you very much. Feel free to ping me anytime if you got any questions. Happy to discuss them. Also, if you are looking for a new challenge, there are plenty of open positions and great opportunities if you would like to work with us. Now I'm looking forward to a fruitful discussion.
Thank you, Hendrik. That was really interesting. So if you would all like to join me back on the stage, Peter, Uwe, and Tom, that would be great. And we can start the discussion. And the first idea I would have, Hendrik, wouldn't it be a good idea to get Lufthansa Technik as a customer, and if they already have an installed 5G network, and use your teleoperations activities there? Would that be possible?
I think that's a great idea to put a map of all the 5G networks over our potential customers and align our efforts there, since it makes our lives obviously easier, and there are some synergies if we have already 5G rolled out and can provide a use case that actually makes sense. We should work together, and happy to discuss this with the customers.
Tom, what do you say?
Happy to do so, to map it against our business development activities over there. It would be worthwhile a chat, definitely. I mean, one remark needs to be made here. As we talk about 5G networks today, we need to look into the details with regard to the availability of the ecosystem, especially on the device side, to support that. 5G is in ramp-up mode, specifically for the campus networks and in standalone mode, and the variety of devices today available is still very limited. So the idea to start with 4G and to use the benefits of a cellular technology like 4G, this was a good idea, and we actually promote that idea, and we do so in many countries and with many customers as well, because there the ecosystem is existent. But yeah, nothing speaks against combining business development activities.
Mm-hmm. But Uwe, and maybe also Peter, that's one question that occurred to me while I was listening to your information. You have the chart sort of with the roadmaps of the development of 5G. That looks like it's a stable path towards a ubiquitous 5G. But is that the case? Where are the roadblocks, or is it so clear that it will develop in this stable manner?
Yeah, maybe if I go first, I think for sure what we try to do is that we have one global standard, because cars, for example, move from Germany to Austria. So you need to ensure that you have the same technology, and you have also that the data can move accordingly. So 5G is not like that there are no risks, because we have a lot of geopolitics involved, you know, that every region wants to have making their own mark into the standard, but we have been uniting that one. And what we also have is the real estate where we deploy the 5G network. So we need to have the frequencies in the spectrum as outlined. And I think here we have a very progressive regulator in Germany with the BNetzA, which, for example, open at a very reasonable price those spectrum for private deployments at industrial sites, which is key in order to enable the business case for that. So it's a consorted ecosystem approach, and we need to have also the boundary set from the regulation and from the governments, as well as from us who are driving the industry and bringing products to the market.
So are you saying that the standard is there, but it's not, or could be there, but it's not been accepted by everybody, or is it not really there yet? Sorry if I ask again.
Peter is now somehow locked,
Frozen?
it looks like. Yeah. But maybe I start answering. I think we need to separate between the standard, the evolution of the standard, and also the agreements on the standard, and what an operator like Vodafone, Deutsche Telekom, AT&T, China Mobile, what they implement in their network and operate. That's the first point. There are operators which are extremely fast, innovative, and where the geographies and the population densities, etc., justify an extremely quick and fast rollout of 5G technology, pricing models, etc. And in other areas, other geographies, it takes a bit longer to get everything covered. So that's one thing. The second thing is the regulator is different in every country. The German regulator did not only allocate spectrum for enterprise networks, but they also associated heavy obligations to cover roads with the 5G license. And there we are fairly advanced in Germany on this topic. Other countries have not put such heavy obligations with the license. So that's why we should expect a reasonably fast coverage of the main roads with 5G, because it's part of the license. And the operators are forced to do that. So that's another an element. A further topic is everybody should understand that there is no hard separation between 4G, which you have today everywhere, nearly everywhere, and 5G. This is a smooth evolution. And in the same way as your smartphone, when you make a phone call, you wouldn't realize whether it's using the 3G network or the 4G network. And you actually don't care as long as the quality of the call is good. Yeah, you notice it when you have an application, a video application, then obviously you are affected by the capacity of the network. So, and the same thing is with 4G and 5G. They are still investing into 4G. In some areas, they are investing into 5G, and you will drive along. Important is you have connectivity, and step by step it will get also higher quality 5G.
Okay, so to summarize, that means that you're actually quite happy with the status of it right now in Germany, at least. I mean, we're always complaining about the insufficient digitization in our country, and also the unsatisfactory infrastructure for it in terms of Glasfaserkabel and all that. But in this case, you're saying we're actually in quite a good state. That would
we have improved quite a lot in Germany. Okay. So there is a lot of momentum today in this segment, rolling out fiber, putting more 5G base stations in place, etc. And let's not forget, one thing, it is the connectivity, but digitalization of road infrastructure, for instance, is not just about connectivity. Yeah, it is much more. To connect all the traffic lights, for instance, to a central management system, and then to be able to manage those traffic lights also, and to provide the information also to other participants. So these are related, but still different things, and require different investment. Yeah.
Now, the Netherlands is a much smaller country, but that could be one explanation. But why are they so much more advanced in supplying their infrastructure with this connectivity?
You know, Netherlands, they have a different geography. They have also different density of the population. And one thing is very interesting, what the German regulator did with 5G and associate coverage obligations, the Netherlands did already with 3G. At that time, they forced the mobile network operator to provide coverage, and they put some KPIs in place with the 3G auction already, and that now they benefit from that.
So that explains why they would be so far ahead in that. Yeah.
Yes, that's as I said, several reasons. It's not only one. Yeah, it's also the geography is much easier than if you compare Netherlands and Austria, for instance. Then it's obvious. Yeah,
it's flat. Yeah. Peter, welcome back to the table. I wanted to ask.
Sorry, Deutsche Telekom DSL line crashed 6 o'clock, so no 5G.
Okay. I would like to come back to one of the first things you said, Peter. You said turning complexity into efficiency. Now that to me is almost a magic word. Sometimes if I look at my desk, I would love to know how to do that every time on a reliable way, to turn complexity into efficiency. So how is it possible, for example, to increase latency or decrease latency tenfold in only 3 years? How is that done?
Yeah, I think it's first of all that we make use of those software technologies. You know, what previously was done on bare metal and dedicated hardware is nowadays simply a piece of software which you can move around. And if you can move around a piece of software, for example, closer to the base station or to the antenna, you can also reduce the time when the bits and bytes are going to travel. So that helps in order to reduce the latency. And the important topic is to do edge computing. So that means to do the compute of the data close to the edge. So that means close to the road, if we take the example what Uwe had been using. And then for sure, turning the complexity into simplicity is that we make use of artificial intelligence within the network in order to do the optimization of the resources. So 5G is pretty complex because you have a lot of screws you can tune in order to optimize the system on the access network as well as the core network and the air interface. So here we have seen a lot of progress by means of those machine learning, artificial intelligence, because you can find a better solution faster than you have a preset algorithm or that a human is tuning the network. So that also helps to reduce the OPEX and to improve the agility, that you are better using the resources of the network.
Can I ask? Thank you, Peter. Can I ask that question to you also, Hendrik? Where are your greatest challenges in the next year or the next 2 years ahead to turn complexity into efficiency?
Probably not on the network side. So that is the positive answer, since we reduce the complexity inherently by choosing a use case that is in a confined area on these industrial sites where we limit the number of variables. I think that is helpful, and also limiting the focus on one specific use case. And yard tracking also reduces the complexity, since as a startup, I think that is one of our key assets to develop a focus and reducing complexity and accelerating our velocity in developing one solution, since we do not have the resources to solve every possible use case for teleoperation and also not for autonomous driving. And I think this would be my answer, how we turn complexity into what was the wording, in a solution or simplicity.
Okay. I'd like to take up Sure.
I may take Hendrik's solution as a bridge to also answer that question and to illustrate. When we take Hendrik's solution indoors, then all of a sudden the manufacturers, for instance, tell us, you can't just install another network in our manufacturing hall, because we need today already an automation network, we need a telephone network, we need a data network, we need a positioning network because GPS is not working indoors. And now you put on top of that a 5G network. That complexity is ever increasing, and this is not manageable. So the expectation there is certainly that with the introduction of a new technology like 5G, which is a multi-purpose technology, we decrease complexity and that we take out of that stack at least 1 or 2 layers. So by definition, we already combine the data layer with the voice layer, for instance, because we transfer voice over IP, for instance. We also start now to combine the IT layer with the OT layer, which is the ICT-OT convergence. And then on top of that, we also provide positioning out of the 5G network natively, where we can skip the either GPS layer to a certain extent, or the additional ultra-wideband or low-power Bluetooth layer, which is used today in manufacturing, for instance. So in that, we combine different layers into one, which does make the one layer even more complex, and we rely very heavily on automation in that layer as well. So we need to do our homeworks on the network kit side, that we automate and make those networks by in itself more intelligent, but we reduce the complexity for the customer and that we reduce the number of layers in the stack. And I think this is a very powerful means going into future to master that complexity.
Thank you very much. I think that makes a lot of sense. Yeah. I have a question here from Philip Walk from our audience. Hi, a question to Nokia. Since car manufacturers working on own solutions for V2V, what do you think would be necessary to convince them to agree on a common standard for V2V or V2X? So that's maybe for you, Peter or Uwe.
I think Uwe, you're the expert.
To be honest, I'm not aware that they are working on their own standards for V2V. The reason is V2V is between vehicles, direct communication between vehicles, and that makes only sense if you can communicate between vehicles of different car manufacturers. So they need to be aligned, otherwise it will not work. And everything we know is there are currently, and that's unfortunately a matter of fact, there are 2 standards which support V2V communication. One is relying on wireless LAN technology, so IEEE technology, and that was basically the development started around 20 years ago for this technology, but also it has quite a long life already. It has not been widely deployed by the automotive industry. And the second technology is the 3GPP, so the mobile industry technology, and that's also standardized, well standardized interface, and as I mentioned in the presentation, now the Chinese vehicles start hitting the road, and more of those vehicles are equipped with this technology, and it is a standardized technology. And it's not just the standardization of the radio connectivity, it's also the standardization of the messages which are being exchanged between the vehicles. And that is ITS, ETSI ITS messages. That's the common standard.
So are you saying with the deployment of these vehicles, whoever deploys the most first, then that will be the standard? That sort of de facto sets a standard?
Well, this is they are following standards in China.
So it's already there. Yeah.
There are small differences between the regions. That's a matter of fact. But this is, for instance, the US. They have a slightly different approach, but this is not fundamentally different. These are smaller differences. Okay.
Well, thank you. I think we could go on a long time discussing this. I would like to give people to discuss with you directly in the networking. But I have one last question I would like to put to this round. Most of you said you were quite happy with the legislative situation currently. Are there any wishes, if you could place them? Where would you feel improvement would be good?
If I may start, one thing which we are talking about in different fora in Germany and also in Europe is that whenever investment goes into road infrastructure and public funding is applied or used, special public funding is used for that, then we expect that this is also going into digitalization. It's not just putting a traffic light there, but it is about an end-to-end digitalization of that new infrastructure. And we expect from the government basically that whenever funding is applied, then there is an obligation to include this digitalization effort as well. So that is one of the requirements we have put on several tables.
That makes a lot of sense, yeah.
I may continue on that one. I mean, whenever we talk mobility, whenever we talk globalization, then it doesn't stop at the German borders or the European borders. I mean, when we talk to the manufacturers, we talk specifically also to the ones who have global operations. And this is not bound to the large enterprises. I mean, a lot of those small and medium enterprises also in Germany are the well-known hidden global champions, which also have at least their customers and their supply chains in a global setup. So it does mean whatever we do, we may be happy here in Germany, but we should try to bring those things in an aligned manner to a global scale. And the European scale is not even big enough because especially for manufacturing, we talk a lot of Asia, we talk a lot of America, etc. So this is certainly something which is on the wish list, that efforts are being made to harmonize on a global scale. I think we have achieved something there already, also with 5G, because for 5G, for the first time, at least the spectrum bands are harmonized. So we are not talking about a scattered puzzle of different patches here and there. We are talking about harmonized bands, which makes it much easier also for us for the development of the network kit. But we aren't there yet because obviously, as Germany is a front runner with the private spectrum, for instance, it makes it difficult to roll out such a blueprinted solution on a global scale.
Thank you. Hendrik, any wishes from your side?
Yeah, so when I look at regulation, I look at it from a different angle. We talked a little bit about the frequencies and the standardization and regulation around that. And I heard today and learned today that Germany is quite progressive there. I have the same feeling for the regulation of autonomous driving with the current discussion in the parliament with the new legislation around AVs, and I think this is a great step. Also, if you are working on teleoperation, it requires in the future that there is someone in a they call it technische Aufsicht in a control center that is basically tele-assist functionality required per legislation. I would like to put that discussion further to the next step of allowing human-robot collaboration and building the functionality for that. And for that, my wish is that we get the possibilities to test these functionalities and also the at some points public funding to bridge the gap to commercialization there. And I think we are as progressive as with standardization and regulation around frequencies.
Okay, thank you very much. I think it's time to move on to the smaller and more comfortable tables, maybe into smaller groups. Hope many of you will still join us. The speakers of this evening's panel will be available at smaller tables. Our colleague Claudia will guide us into the networking section. And I'd like to say a very, very big thank you to all of you, Peter, Uwe, Tom, Hendrik, for being here tonight, for sharing with us these important aspects of your work. And I hope everybody has learned as much as I have this evening to understand 5G better and the challenges and also the benefits. So thank you very much, and join us again next time, and see you at a table. You'll have to provide your own glass of something. See you there.
Thank you very much for having us.
Thank you.
Thank you.